Welcome. This is a live session about building Decentraland scenes. My name is Carl Fravel. I am quite active in Decentraland as a builder, a landowner, district leader, and a teacher. I do have slides for some of this to kind of guide us through it, but going to be a lot of action on the screen. Purpose of this demo is to give you an overview of creating scenes in Decentraland by taking you through some of the basic workflows of creating scenes. Show you some of the tools, some of the ways that I work. This presentation is being recorded. It should be available later both in this Twitch channel and in YouTube. The links will be available in the Decentraland blog and in the university Discord server in the VR Academy lobby channel. You will also find there a more complete course that goes into more depth in all of these topics in the university Discord. So you're welcome to visit that. There's a whole collection of YouTube videos that go into much more depth on all these topics. So let me just say, you don't actually have to own land to learn these skills and put them to use, although you probably will want to own some land on which to deploy your results. But you also can work with somebody who does own land and who needs your help in building on their land, such as one of the districts. They have a lot of land that needs to be built on. So by developing these skills, you can be useful, you can make money. References in this video to the documentation refers to the documentation area on the Decentraland.org site. Just to briefly kind of give you a preview of what we're going to look at tonight, we'll introduce some of the following ways of working and tools. How to use the Decentraland map and mark it as a builder tool, as an assistance when you're building. How to visit the world, how URLs work, how scenes work in the world. How to use the Decentraland Builder to quickly assemble a static scene and work with it, and then download that scene to the Decentraland SDK and preview it from there. We're going to look a little bit at the structure of scene folders and the file structure in a scene. We're going to do a little bit of editing of a scene. We're going to look at how you can get custom and inexpensive low-poly models for your scene, things that are beyond what is available in the Builder. We're going to show you how to use Blender to convert one of those models you might get into the format that's needed for Decentraland, which is called GLTF. The GLB is a binary compressed version of that. We're going to look at downloading and modifying how there's a large collection of sample scenes from Decentraland, but their purpose is for you to learn how to make scenes and how to use various kinds of pieces of coding. So we'll download and modify a sample scene. How do you deploy land to a web server other than the land of Decentraland in case you want to use it for a staging area or a testing or a demo area? And then how you actually deploy the scene to land in Decentraland and invite others to come find it and see it. So, the root of all goodness is Decentraland.org, and we're going to go ahead and take a little tour of the website. If you just go to Decentraland, you'll see a colorful landing screen and a bunch of interesting menus up here. So if you scroll down, as it says to do, you back up a ways, and then eventually you actually get to the website. And one of the first things you can do is create an avatar. There's really kind of two parts to this. One is creating an identity and an avatar, and the other is claiming a name. If you want to use your real name, like I'm using Carl Fravel, then you can reserve it. You can buy it, basically, with 100 mana. And there's a good reason for that not being absolutely free. You wouldn't want somebody going and just piling up all the names for free and then holding them ransom. So they have a small entrance fee to obtain your own name permanently. But if we go to the avatars menu or this create avatar, you'll get to see the I have already created an avatar and claimed a name, so you can get to see what your avatar looks like. You can edit it, and in the process of getting in here, you provide your email address, which is kind of the key to your identity at this time. And when you log into various parts of Decentraland, it'll ask you for your email address. It'll send you a code to email, and you use that code to get in. So a lot of the services work that way. In addition to working on your avatar and associating it with your email address, you can purchase a name, 100 mana to purchase it. I'm not going to try to go into cryptocurrency transactions here today, but the the kind of, if you've never done it, you want to go to something like Coinbase and exchange some dollars or fiat currency for some probably ethers. It's a cryptocurrency on the Ethereum network that this all works on. And then you go to either there in Coinbase or in some other exchange, you exchange some of your ether for mana, and you end up working with your MetaMask. A MetaMask, it's a Chrome plugin called MetaMask, and it has, if you're not logged into it, you'll see a fox that's looking everywhere where your mouse is, and if you go to the Chrome extension store, you can get it, and it's from metamask.io, so you can make sure you get the right one. But anyway, so you move mana into here, and then because this is associated with the browser, you can do actions like purchasing things through the browser. So the next thing I want to do is go to what's called the marketplace. It's market.decentraland.org. It's not only where you can purchase land and see what land is available, but it's also kind of useful as a builder tool, because you get a close-up map of part of the world, and you also get a mini-map of the whole world. And this little thing here kind of acts like a cursor. If you click on some other part of the map, you go there and you get to see how much you're seeing. If you scroll out, you can see that you're seeing more. The purple areas are districts. If you click on one, it'll take you there and it'll tell you a bit more about it, like where it is. If you look around, you'll see that there's lots of little gray squares. Those are privately owned lands that are not currently for sale. You can get the coordinates of them by hovering over them. The things that are grouped either gray or this light blue color are what's called estates. An estate is simply a group of parcels that can be dealt with at the same time, like they can be bought or sold at the same time. You can imagine maybe somebody wants to buy a number of parcels for you. You wouldn't want to be going through and buying every one and have somebody else buy one in the middle in the meantime. So the buyer and seller can work with estates. Light blue here are the parcels and estates that are currently for sale. Green are the public plazas. Gray are the roads. And so I'm very active in some of these districts up here in the north. This is the university. This is the conference center. This is the forest. This is Etheria. There's some others over here that I'm involved with, like District X. Anyway, the list goes on. There's about 30-some districts, and they occupy roughly a third of the land in Decentraland. But anyway, the reason this is useful as a builder tool or an exploring tool is because you can get the coordinates of a parcel. And that's important if you want to visit it or if you want to deploy to it. If you want to buy it, you need to know the coordinates. The coordinates are a pair of numbers, typically separated by a comma. And the first one is east-west. It's positive to the east. So we're at just to the left of the center line of the world here. So if I hover here, you'll see that this is 0 and 1. And then north-south is the second parameter. So if we go a little farther south, we have a smaller number. And if we go way up here to the very edge of the world, we'll see that the edge of the world before you fall off, and there'll be dragons, is 150. So the world is 150 plus and minus from the center. And at the very center of the world, of course, at the center plaza, the location here is 0, 0. So if you want to go visit one of these places, let's just say we want to visit the road right here in front of the conference center. So I could get this location, 1194, and what I do is go to explorer.decentraland.org, and I happen to have it's well remembered because I've been there a lot. Now, the world right now, this Explorer URL is part of a closed beta. The way you get into the list to be invited into the beta is to create an identity in the avatars page. You'll supply your email address, and a few weeks later, you'll get an email inviting you to the world. I don't know what the timeline is right now, but it has been some weeks in the past. I think they're accelerating inviting people in now, so you shouldn't have to wait too long. And there will come a time when this becomes all public, and you can just do this. Anybody can just go to a URL here. This happens to be the main entrance to the conference center. I'm one of the district leaders here. And I just want to show you the kind of quality of what you can get in the Decentraland builds. You see the reflection in the glass of the sun. You can see the texture of the bricks. I mean, it's really good quality stuff, right? Here's a map of the district, and you can see a pretty good resolution on the writing. And it doesn't all have to be photorealistic. As you can see, there's some pretty fantastical stuff going on in here. So going back to Decentraland.org, and it continued to explore the menu at the top. One of the important things, and which we're going to delve into next, is the builder. There are several ways of making scenes in Decentraland. The easiest and most directly accessible to anybody is to use the builder tool. And it's linked right here, and you click there. I'm logged in already, but you would log in and give your email address, and it would send you a token, and you'd log in, and then it knows that you're who you say you are. And that also allows you to save scenes to the cloud, not just on your local browser cache. I have a few scenes here that I have made, but the way you make a new scene is you decide, well, how big do you want it to be in Parcels? Let's make a small one for this purpose. I just click there, and in a few moments, I am looking at a one parcel scene. It has some grass texture on it right now. Over here, there are collections of components and entities, shapes and things that you can put on the land. Genesis City was kind of the original one. You have ground materials you can put on to change the way the ground looks. You have natural objects like trees and rocks and plants. Let's put just my favorite tree right here. I think it might look better with grass instead of growing out of the rock. So let's go back to a grassy look, and maybe I want to put an under construction cone here. So I have basically three things in this scene. I have some piece of material on the ground, I have a tree, and I have a construction cone. For each one of these things, you can click it, and then if you decide you want to move it, you use this move tool here, and you can move it around. You can even move it up and down if you want, maybe push it into the ground a little bit. Or you can turn it using the turning tool and place it where you want. And if you want to make another copy of the tree without having to go back and find it again, you can, when it's selected, you can click on the duplicate tool here. And now if I move it, you'll see that I've actually left a copy behind. So you get the basic idea. You can make quite lovely scenes. There's a new pack here, a fantasy pack that has some wonderful stuff in it. If you visit the world, you'll see some scenes starting to be formed with those things now. So I wanted to now talk about, so how do you save this work? If I just close my browser, what happens? Well, by default, the the content is saved in your browser cache, but if you've logged in, it'll save it to the cloud, which is a nice thing. That way, if you've reinstalled your browser or go to a different computer, you can get to your scenes. But you can also preview it as to what it would look like in the world with this button here. Now you're kind of in the scene, in a preview of it. You can walk around, you look around, let's see that the trees are up there. And when you're happy with that, you can close it and do some more editing if you want. But we're going to actually download this scene. And by downloading it, we get a zip file that contains the scene in the format that's needed to do further customization in the software development kit, Decentraland SDK, which, by the way, is very well documented in docs.decentraland.org, excuse me. Again, it's just on the menu at the top. It's docs, and you can learn how to install the SDK and the prerequisites that are needed from it, specifically Node, the JavaScript Node system. Talks a little bit about how to do 3D modeling. The development guide is where you really get in and see all the different things that are available in the SDK. You can add sounds, you can add movement, you can put up text in a scene, you can use external objects, you can use primitive objects in script. There's just many things you can do that are beyond what the builder is basically for building a static scene. They're going to be adding more functionality later for some interactive behavior and for custom objects. But right now it's just a basic scene, just for making kind of a start of a scene, let's just say it that way. Now you can actually, if you own land, you can actually publish all the way to land right from here. But we're not going to do that right now. What we're going to do instead is take a look in this scene zip file that downloaded, because we want to talk. We're going to spend more time with the SDK tonight, not that much more with the builder. This is a directory structure that you're going to get very used to seeing if you're working in the SDK. It has some standard directories in it. Some of them are specifically required. Some of them are just standard practice. So the main couple of files for the scene are the source code for the scene that's in the source directory. It's called game.ts. Now, I've previously installed Code, which is a free version of Visual Studio. It's called Visual Studio Code. It's downloadable for free, and it's a wonderful tool for doing this work. And it is the tool that recognizes TypeScript files. TypeScript is the programming language that is used in Decentraland, and it is an extension of or a object-oriented, class-oriented, type-defined version of JavaScript. So if I double-click on that, I will open it up in code, and we'll see what a scene looks like, what the code of a scene looks like. Code, Visual Studio Code, which is I'm just going to call Code, does syntax highlighting. It can tell you that it knows that const is a word in the language, scene is some variable name that you've defined, entity is a class, etc. And the sections of code in here, for example, this one is the tree, and this is the base grass scene, this is the construction cone, this is the other copy of the tree. At the very top, there's a section that's defining the scene as a whole, and each of the parts here, each of the sections set the parent of this object to be the scene as a whole. And we're going to be looking at this quite a bit more. But I want you to notice that code is also telling me that it looks like I have syntax errors here. It's a bunch of stuff underlined. And it's because I'm looking at this piece of code out of context of the shape of what a set of files need to be in your file system to make it happy. And we're going to go there next. So the The next thing we're going to do is we're going to create a default scene with the SDK, which I've already installed. So I've been working in a number of different web VRs, and in Decentraland I have a folder structure here. And we're just going to go into my experiments directory where I do various things like this. And we're going to make a new scene. I have a number of them in here. So you want to organize your scenes. If you end up building all the scenes, your computer could get quite cluttered if you don't kind of think about organization. So in my user or home directory, I have a directory structure that gets down to where I work on scenes. If I go up one directory, you'll see that I actually have folders here for various districts that I'm helping with. I have a library of reusable stuff that I've put up in the public in GitLab, and we'll look at that a little later. So I want to go into experiments. And I don't think I have something called demo. So demo, I'll make a directory called demo. And I'll go into that directory, type C and an F3 to type the rest of that again. And this directory is empty. But if I do DCL init, this is the kind of how you get a new scene started using the SDK, which, like I said, I've previously installed, and you have to have it installed to do this. And it builds a scene. You'll see the same kind of directory structure here as we saw in that zip file. So just do a directory here, and again we have the src directory. And here's game.ts. Let's take a look at that game.ts file. It's laid out a little differently. It has less code. There's less things in this scene. It's a very simple scene. Let's take a look at what it looks like. So you do that by previewing the scene, which is the DCL start command. If you have a scene that's been created, either with the builder or with DCL init or some other methodology, and you go into it and say DCL start, it will do some work to prepare it for being previewed. And I did this in the wrong directory. This is something that happens quite often. I'm in the source directory. I want to go up a directory and try again. Oops. Up comes a browser. DCL start basically does a build of the scene and then opens the browser so you're looking at it. DCL init makes a single parcel scene. And by the way, when you enter the world, you enter at coordinates 0, 0 unless you specify other coordinates. When you enter a scene, maybe you've given some other coordinates, but in any case, you start at the southwest corner. You're standing at the southwest corner of the scene, of the, basically usually the southwest parcel in the scene, but the parcel is called the base parcel. So you start at the southwest corner of it, and I see a cube here. It's rotating. Let's take a look at the code for a moment and see why it's rotating. I'm going to kind of start at the bottom here. There's a cube that's being created. It's being created by a call to spawn cube and the location in the scene where the cube is spawned. Well, these parcels are 16 meters by 16 meters, so the middle of it is 8, 8, right? 8 meters east, 8 meters north from the southwest corner. Also, this cube is up in the air a little bit, as you can see. And so this is the east-west distance from the southwest corner of the scene. This is the north-south distance. This is the up distance from the ground in meters. So what is spawn cube? Well, spawn cube is actually just a local function in the code called spawn cube that takes these three parameters and does something with it. It does the things that you typically have to do to create a visible entity in the world, such as instantiating something called an entity. Entity is part of the SDK. It is a point and orientation in space, but it's not visible in itself. It's just a location. That location is going to be placed at the parameters passed in, 818, which become turned into a vector and set to the position attribute of a transform, which is another SDK class. Transform has to do with location, rotation, and scale of an object, but you don't have to specify all that. So this cube has initially a default rotation and a default scale, which is ×1, or in this case 1 meter on a side. And its position is placed where the parameters that were passed in here are, at 818. And then to make it visible, we have to add a shape to it. This is an example of what's called a primitive shape. It's built into the SDK. You don't have to have an external mesh model file to define it. There are a handful of built-in shapes. They're called, by some people, called primitive shapes. So it's a box shape, and that's been added as a component to the cube, as was the transform was added as a component to the cube. So this is called an entity component system, and it's quite popular in game development and other code development. It lends itself also well to tools like the builder, which generate this code. So we create the entity, we use a transform to position it and add that transform component to the cube. We define what shape we want it to be using a primitive shape, a box shape, and add that to the cube. And then we say engine, which is the kind of the runtime rendering equipment in the SDK. It says add this cube to the engine so that it will get visible. If you don't put this in fact, let me just demonstrate that. I'm just going to comment this out by putting a couple slashes in front of the line and save it. You can see I haven't saved the file because it's a dot up here. When I Control S, it saves it. Go back to the scene, and that cube's going to disappear when it reloads the scene. Come back here, turn it back on. Control S, back here, and the SDK reloads the scene when you make changes to game.ts. I want to make this a little bit bigger. So I'm going to add some more information to the transform. In addition to having a position, I'm also going to say scale. It's another attribute. And by the way, code is very smart. If you start typing here, it says, oh, of the things that you could type here, scale is one of them. In fact, if you hover here, of various things here, you can see what the expected parameters. It really helps you a lot when you're coding. So I'm going to say another vector 3 of, instead of 111, which would be the size it is by default, I'm going to make it 2. Now it's not happy here because it's a syntax error. I did put scale in this time, scale. And when I have it right, all the red disappears. When you have it wrong, you also get a red dot over here. So you can see all the red dots all through your code where you have errors. So that box will be bigger now when I go back over here. And indeed it is. You've got 2 meters on the side, you can see that. All right, so I'm going to take that back out of here and show you what else happens in this scene. In addition to adding these other components, we've also added a component that is an OnClick event handler. If you click on the cube, this OnClick handler gets called because it's been added to the cube. And it is what's called a lambda function. It's a function without a function name. It's just saying, do this stuff when the OnClick event happens. And what happens is that it makes the Z scale bigger by 10% times 1.1, and it makes the X scale, remember these are the 2 horizontal scales, it makes it smaller every time you click on it. It also spawns another cube with random position, but default size. And so let's see what happens here when I click on the cube. I click on it. Oh, it got smaller in that dimension and bigger in the other dimension. And somewhere around here, there's probably another cube. Where is it? I see a shadow. There it is. Oh, and it's spinning too. Interesting. If I click on this a few more times, it gets longer and longer. And I get more and more cubes. And they're all spinning. And in fact, these cubes have colliders. And so it's going to sweep me right off the scene when it gets around here because it's going to push me. So objects can have the ability to have colliders, which means you can't walk through them, and it means you can stand on them. But objects don't have to have colliders, and they can be phantom, and you can walk through them. So let's go back and look just a little bit more at this scene code and see why it's doing these other things. So when I spawned a cube up here, I called spawn cube, and it made another one. But at the top of the code, I have a system. A system is, there are two kinds of things you can add to the engine. You can add entities, like here. Nope, like here, where I added a cube entity to the engine, so it would be rendered. But you can also enter, add to the engine a system. A system is a class. Typically, it implements the iSystem class, but what's most important is that it has the update function in it. An update function must be in a rotator system for it to work right. And the update function gets called 30 times a second once this thing's been added to the engine. And so if you want to do something in your scene over time, you implement one or more rotation systems or other kinds of systems, each of which has an update function that gets called 30 times a second. The parameter, dt, is delta time. It's how much time has passed since the last time this was called. The very first time it gets called, it's pretty close to 0, but thereafter it is a 30th of a second, or very close to it. And in this, every 30th of a second, we're looking at all of the entities that are obtained from this mechanism, which I'm not going to explain. You can look at the video from Interweaver last night, and he explains that some more. You can look in the documentation. But basically, it's rotating every one of these by rotating it around the up vector, which means it's rotating around the vertical vector. And it's doing it by an amount, which is a 30th, 1/30th of a second times 10 degrees. So, like 0.3 degrees. That's why it's rotating kind of slowly. Let's have them rotate faster. Let's have them rotate 10 times as fast. When I hit Control S here and save this, it's reloading the scene, but it's not reloading all of the stuff it had before. It's reloading the original one, but you can see it's rotating faster now. And if we, say times -100, it'll rotate the other direction. So you get the idea that in code you can generate behavior. Let's see what I was going to do next. Hold on a second. Get back to my slides. I think we've done these things. Let's now look at that, the scene that we downloaded from the builder. I'm going to close this for a moment and go to Explorer here. I downloaded that. That should be in my downloads directory. When we did the download from the builder, this would be about the right time. I think that's when we have open here. New scene 8.zip. Okay, so what I'm going to do is I'm going to take and create a new directory. Control C. Yes, please stop that engine that's running that other scene. In fact, let's close that browser. and I'm going to make a another scene. And I'm not going to run DCL init in here because I'm not particularly interested in that rotating sphere. Instead, what I'm going to do is I'm going to take the contents from this zip file, go up one unit, take these, all the content here, Control C, go over here, Control V. Oops, not in the command window. You got to do that in a Windows Explorer, of course. Experiments, demo 2. It's an empty directory, Control V, and it puts all the stuff from there. Let's take a little deeper look here, because the previous scene was pretty simple from DCL init. It didn't have a models directory, but we have all those models, the tree and all those other things. And so let's just drill into that for a moment. Somebody's done a good job here of organizing the models directory to have subdirectories for each object. So let's look at the tree. The objects in the library are a little unusual because they're GLB files, which is the compressed binary version of the GLTF file format that Decentraland uses. But their color is actually in a kind of a standard external ping file instead of being built into the GLB. You'll see that from the builder objects, but not typically like if you export from Blender. If you export a GLB, everything will be packed into it, and if you export a GLTF, you may see multiple color texture files. If I double click on this GLB file, it'll open up in a tool in my operating system, which is Windows, called 3D Builder. And it doesn't look quite like what we were used to. That's because it's not only the model, but it also contains a collider, so you cannot walk through the tree. It's not phantom. We'll talk a little bit more later about how you make colliders for Decentraland. There's 3 directories here. Even though we have 2 copies of the tree, we only need the mesh one time. And in the floor base, we have a GLB and its grass texture. Construction cone. Again, it's using some of the bits of color out of this. And otherwise, this looks just like what we had before. The game.ts is in here, but let's take a look at what's in it. This is a pattern you'll see anytime you export from the builder. So why are we getting syntax errors here? Well, it's because I haven't put the rest of the SDK into this scene. So there's really 2 parts to the overall SDK. There's a part that runs the DCL commands, and you install that globally using, by the way, just so you'll know, once you have Node installed, you install the current version of the SDK, the global part that runs the DCL commands using the Node package manager. You do the I or write out the word install. You install it globally and the word Decentraland. Now, there's no harm in reinstalling something, so I want to kind of show you what the output looks like when you do that. And if you see some warnings and errors, it's not necessarily that things are broken. You kind of have to look at them and see. But the current version of the Decentraland command tools, the command line interface, is version 3.27. But the other thing that I don't have in this scene yet is the local part, the part that goes in the scene and gets deployed with the scene. And that is done by using, and when you use DCL init, it does that automatically for you. But if you've gotten the scene from somebody else, somebody's sent you a zip file, or you've downloaded one of the sample scenes, it typically doesn't have all that stuff in it because it's very large. So in the local directory, if you haven't already done DCL init, you'll need to do npm I, not G, not -G, because we're not installing this globally, Decentraland -ECS, Entity Component System. the warnings that you get here when you install the ECS part of the Decentraland SDK are normal. And you can see that the version that installed is the latest version, 6.3.1. And now if I simply close code and reopen it, this is something you're going to end up doing sometimes when you don't have the local part of the SDK in the scene yet. You're going to get a lot of syntax errors until you've installed it and then close and reopen code. And now it says, well, I know what a transform and an entity are. And the reason it does that is because in this directory we have now a node modules directory. And it's large. I'm going to open up the Explorer on this scene and do a properties on this, and you'll see that it's 74 megabytes, whereas the rest of the scene without that is only less than a megabyte. So if you want to send a scene to somebody for them to look at, you want to report a bug, you want to get some help from somebody in the university, whatever, you want to zip up this directory, the contents, but you want to exclude node modules. You can also exclude the bin directory and the package lock folder, bin folder, and the package lock file. Those will get recreated when they do an npmi and a build. So if you want to save yourself some space, but just at the very least, don't include node modules in the zip unless you want to send somebody 75K of stuff that they can recreate in a few seconds. Okay, so we have this scene that we downloaded from the builder. It's here in Demo 2. We have installed the other part of the SDK, and now if I do a DCL start, it will determine that it has to do a little bit of building. It checks first that the SDK is installed, and it means the ECS part. And this time what we will see is what we built in the builder. Now, you can, if you want, you can go back to the builder and make some more changes and bring it back in here, and go back to the builder and make some more changes and bring it in here, and eventually deploy from either the builder or here. But as soon as you make customizations here, you can't take it back to the builder. The builder exports, but it doesn't import SDK. It will import the zip file. If you take that zip file that you got and re-import it into the builder, it knows how to get the thing out of it that it needs, which is one particular file that is not technically part of the SDK, but it's this builder JSON file. This file is really what the builder uses as input out of this zip file. All the rest of it is its output. So if you open up this builder.json file, it's not really superhuman readable, and it refers to all the content in an obfuscated way. It's the way it's uploaded into the content server. But the rest of the files in here are SDK files and game.ts in the source directory. Looks like what we've been looking at. So it creates an entity, a transform, in this case with position, rotation, and scale. All the outputs from the builder use all three because you may have moved it, you may have rotated it. So it always supplies all of them. For the scene itself, it says it's unrotated, it's positioned at 0, 0, and its default size, so that all of the children to it are attached to that origin. Let's just look through this code a little bit. It's a little bit more complicated than what we had in the other, because you're using external GLTF shapes from these GLB files. So the first thing that's done is to create an entity, which is a place in space where the tree is going to be. It's not, the position is not defined yet. It's just think of it as a point that isn't anywhere yet. And right off, you're saying make the scene the parent of this tree. The nice thing about that is if you needed to move the whole scene a little bit, in the world or in a space, and maybe in a larger scene, you can adjust the coordinates of the scene, and everything moves because they're all parented to it. It's very nice. You can use parenting, you can use multi-level parenting in a scene. So you may have some sort of a complex component made of a number of objects in a scene, and you want to move that group together. I might show you an example of that later. The next thing you do is, the order in which you add these components doesn't matter. So in the builder output, it adds the shape first. And instead of a box shape, it's using a GLTF shape, which has a constructor that takes a parameter, which is a quoted string of the location of the GLB file relative to the base directory of the scene. So you have to say models first, because it's down in the models directory, and then another directory name, which is because there's a directory for that tree, and then inside that tree, the GLB file. It seems to be standard practice to use single quotes here. I'm not sure that it matters. And then once you've created that shape is just a shape. It's not located. It's not in an entity yet. It's just the shape of an entity. You add that as a component to the tree entity. And then you add a transform to it by defining the new transform and adding that to the tree entity. And in the transform constructor, you're saying position, rotation, scale. Now, rotation intrinsically in VR systems or three-dimensional systems is best defined as a quaternion. It's a four-parameter constructor, 4 dimensions, X, Y, Z, and maybe a W in the beginning. Anyways, four dimensions, which is rather confusing because the rotation is, you would think of as being a rotation around 3 axes. It's a better way of representing rotation because you can keep rotating a quaternion without any kind of weird things happening, whereas with the other way of specifying a rotation, which is called a Euler, which is a 3-dimension rotation definition, you can have some problems when you do certain kinds of transformations with it. So quaternions are used, but they can be kind of confusing. So there is a method on the quaternion class called, this refers to it as Euler. You can find out a lot more about that if you really care in the Decentraland docs. All right, so there's a tree, the ground, the construction cone, and another copy of the tree. Now here, there's no model defined like there is here for the tree. And why is that? It's because you've already made a GLTF shape for the tree, and it is reusing it here, right there. In fact, if you, in Visual Studio Code, if you select something, you get to see all the places it exists in the code. It's nice. So if you double-click this GLTF shape here, you can see that it is used. This is a different variable because it has a 2 on it, but down here you can see that it's used explicitly, so you have the tree again. If I were to take instead and put this here into this, I would need to take a whole line like this and put it down here and put a different model in. It would come up a different shape. The position of this tree, 6.5 and 7 on the ground, is different than this tree, which is 6.5 and 3.5 on the ground. So we moved it in one of the dimensions. We moved it, second tree, to the north. So that's kind of the basic structure of what's in code. You can write this by hand. You can have the builder start it for you and then make modifications to it, like if you want to set up a rotator, if you wanted to resize something. Currently the builder doesn't support resizing, so you could come in here and change the scale of a tree. Let's make this tree taller. Taller is vertical dimension, right? So that's the middle dimension. Come back to the scene and we'll see this tree get twice as tall. He says, did I kill the scene here? No. Well, let's just reload it. I'm not sure why it didn't reload. I am running it. Well, let's figure out what I didn't do right. I'm in the directory demo2. Oh, maybe I didn't save it here. Did I not save it? No, I saved it. I'm slightly mystified. Let's start the scene up again. I guess I could leave this for homework for you guys to figure out what the reason for that is. Yeah. I know there was something about the reload that didn't work. But now you can see this tree is twice as tall. All right. Also, it isn't quite on the ground, is it? That's because we have ones in here, probably. For the tree position, it's not quite on the ground, half a meter up. Okay, so let's kind of see where we are in the plan for tonight. I want to show you another really important file in the scene directory, demo2. In addition to the game.ts file that's down in here, there's another one that's really important, which is the scene.json file. It's important for two reasons. One is that it tells you where the scene is in coordinate space of parcels. It also tells you how many parcels it's made of. There are some other things here which are largely optional. If you want a title on the scene, if you want to claim that you did it, if you want to put your email in to make that available to other people, you can do those things. But these two, this section right here says how many parcels are in the scene, which parcels they are, and which parcel, the base parcel, is the coordinate origin in your scene. If you're making a really large scene, it can get kind of tedious to do like this again and again. If I hit Control S here, I think we will get a scene update, and we get a, in addition to the southwest corner having one parcel, there's a parcel to the north. Why is it to the north? It's because of the fact that I changed the second parameter, which is the north-south parameter. If I do this, notice I'm not putting a comma after the last one, only between them. Come back here and we'll have an L-shaped parcel because I put one to the east now. If I want to fill it out, I put another comma and 1.1, 1, and now we have a 2x2 scene. You can do that in the builder as well. Maybe you want to do something else on the ground in other parts of the scene. Maybe you just need a bigger scene. You started customizing this, you can't go back to the builder to rework it because you've put interaction and stuff in, but you decided you need to make the scene bigger. You can do that by enlarging the parcels here and then putting other content on the land out here. I have a tool. I hope this URL is visible in the projection, but it's fravel.net/webvr/estate-gen/estate-gen.html. It's a little tool for building a really large parcel list. Let's say you have a piece of land that's at 23 on the west and 30 on the south. I'm on the east, and maybe it's 3. The southmost parcel is y coordinate 3, and the top one is the northmost is 5. And you generate coordinates, and you get a list here that you could copy and paste in here instead of this. Now, there's 2 problems with this right now. Number one is this base parcel isn't any one of these. It has to be one of these. And my tool generates the southwestmost parcel first, and that's typically a good choice for your base parcel because it means all your coordinates in meters in your scene are positive to the east, positive to the north. So let's do that. The other problem with this is that, where's my scene viewer? It's on one of these guys here. The problem is that my scene just disappeared. Where'd it go? Well, it went up north somewhere, right? It went to 23.3. Even though I'm in the preview, the coordinates matter. So if you're building something to place into the world at some place other than 0, 0, which you don't own and you can't deploy to, you need to be cognizant of, once you've changed the coordinates in your scene.json in preparation for deploying it to the right place in the world, that you won't see it at 0, 0 anymore, and you have to do this. Here it is. And just so you'll know, as you move around in the world, these numbers here change. The percentage 2c is a representation in ASCII of a comma. So it's just 23 comma 3. But if, let's say if I go north, I should expect that second that 3 to become 4. Okay. When I cross into this scene, I'm 4. If I go here, I'm 5. If I go out of this parcel to the next one, I'm 6. So you can always tell your way around in the world, I mean where you are, simply by looking at the position parameters on your URL in your browser. Another trick is when you first arrive in a scene, either in the previewer, as a DCL start, or in the world, you're facing north. Unless the scene has done something to turn your avatar or something in the future, you're facing north by default. And the other way to tell if you're all turned around and you've done this and you don't have any idea which direction is which, is look for the shadows and look for the shininess on the direction the sun is on the ground or on things. It's there, right? That is southwest. For now, the sun is southwest. It doesn't actually show in the sky, although it does reflect off of mirror-like surfaces. All right, so you saw how to use the marketplace map to find out where something is. If you know where your parcels are, you go, if you bought a parcel, it'll show up orange when you log into the marketplace. We weren't logged in when I was there. But your land will show up orange. And you can figure out what the coordinates of it are if you don't already know by looking there and then placing them here as you're building your scene. You place them here as you're building your scene. Whichever parcels you have, and then make sure one of them is your base parcel. And then when you want to visit it after deploying it, you look here. So let's actually deploy this scene somewhere. And jump ahead a little bit to that. I have been teaching a class in the VR Academy of the university, and we have some land that Decentraland has very graciously loaned to us for a sandbox for our students. And it is here. It's some 45 parcels. Thank you very much, Decentraland, for that gracious support for the class. And we're now not going to DCL Start, we're actually going into the world. I'm sort of at the northeast corner of the sandbox, and you can see that various things have been deployed here in the sandbox. If you come down here a little bit, we'll see some other things. This is the center of the sandbox here. There's kind of a gazebo with which students' things are where in the sandbox. We have around about 30 students who have gotten far enough in the class to deploy things to the sandbox. If you want to come visit this particular parcel, it's at -140, -85. And this URL will take you to the Building in Decentraland course. Some of the other student deployments are here and quite lovely. Some very talented builders. Somebody's built something really interesting in a modeling tool that's it's shiny. I don't know if you can see that. It's very reflective. Anyway, some nice stuff. But we're going to deploy something to where I started, which is up over here in the northeast corner of this. I had it here as -138, -81. So in here, I'm going to put that in as my base parcel, -138, -81. And that's the only parcel that the scene can have in it. So we're going to replace all this with just that one parcel, like that. There's no comma after it because it's the only one there. So the parcel list has to live between these square brackets, comma-separated parcel names that have no space here. Do not put a space there. It doesn't work, in quotes. And now, this scene, I've just saved that. If I go back to the preview of that scene, let's just have it started up again by going to the command line, killing it here, and going DCL start. This scene should now again be just one parcel, but it will be at a coordinate that is -138, -81. So when the previewer comes up, the previewer has been improved recently to take note of the base parcel in your scene, and it actually loads you there. I find that it doesn't work all the time, maybe because it's not doing a deep enough reload sometimes or something. But anyway, you can see now that it has actually placed me at the right place in the preview space. This is a local URL, IP address of my machine. But let's go ahead and deploy this to the land. Now to do that, you have to have MetaMask hooked up as a Chrome browser extension, and it's got to be logged in as a into an account that has the permissions to write to that space. And this Decentraland University extension updater is an account that can write to all of this estate. So I'm properly logged into that, and I come back here. I stop my local preview engine and close some windows here just to get some memory back. And I'm going to do DCL deploy. This is a command you can do when you own land or have the rights to write to it, and you're in a directory that has a scene whose scene.json file, this one here, meets the requirements of you own these parcels or have the right to write to them, and this base parcel is one of those. So the deployment will look at this to say, where are we deploying this? And then it'll look at your MetaMask to see if you have the rights to deploy to that land. This should work. First thing it does, it says, well, this is all I'm going to deploy up there. Are you sure you're okay with that? And let's just look at it for a moment. The builder.json file should probably not be deployed because it's not needed for the SDK scene, and it's needed by the builder but not for deployment. So let's hide that. Let's not have that go up. And then you do need to send up the game.js file out of the bin directory. That is the result of the build process that just happened here, or when I did DCL start last time. This is what actually runs the scene. Game.ts is compiled into game.js. And here are my models and my scene.json. The models have the ping files as well as the GLB files. Everything's good, except I don't really want to deploy this file. So how do I keep that from happening? I'm going to say no. There's a file that may or may not be present, but it's called DCL ignore. And I'm going to edit it. It says what may be in your directory, but you don't want to deploy. Here's a list of things. Any files that look like this should not be deployed when you deploy to the land. This one did not have in it, what was the file we didn't want to go? Builder.json. It's only used by the builder to reload the file back into the builder. Anything you do in the other files doesn't go back into the builder. So there's, I want to show you folks something here, which is where you can get a much more complete DCL ignore, and maybe other things that could be useful to you, which we'll talk about a little bit more. But one of the popular ways of storing things, like scenes, where other people can get to them, is using a tool called Git and using a web service for storage, like GitHub or GitLab. I happen to like GitLab the best. And you don't need to be logged in to, actually, let me not log in so you can see that you don't need to be logged in. I have a group up here called DCL Tech, and a bunch of scenes, repositories in it, projects. And this scene-based project is where I keep a whole lot of things that I use all the time in scenes. So one of the files in here is a more complete DCL ignore file. I'm not going to demonstrate getting the whole directory right now, but I'm going to just take all this, and I don't have builder.json in here. Oh, there it is, Oh, it's builder.json. Or is it? Builder.json. Okay, so I'm going to have to fix that. But other than that mistake, it's a good builder.json. I'm going to replace all of this file that's in that directory, that DCL ignore file, with the more complete list from my tools. Try to deploy again, and this time builder.json is not there. So I'm happy with this deployment, so let's do that. So I'm happy with this deployment list, so I'm going to now when you run DCL deploy, it's going to ask you to sign the delivery. And you do that on a web page that it pops up called link scene, and you have to be signed into MetaMask with the account that can write to this location. And it isn't complaining up here. If you didn't have the rights to write here with the wallet that you sign into here, it would tell you that you don't have the rights to deploy here. But everything's happy. It's a long page, so some of the stuff you want to see is down here further, like the sign and deploy button. So, and it's telling you where it's going to deploy to. Let me just grab that. So it's in my clipboard. And sign and deploy. MetaMask pops up and says, are you really signing the idea of deploying this content to that land? Yes, I am. And what you don't see is right below this button, so I scroll down a little bit, content was successfully signed as being uploaded. So I go back to my command window, and you notice that even though it had told me it was done, the cursor took a little bit longer to come back to me. So the green deployment complete can sit there for a little while before it's really completely done. But there was no errors here. Everything's good. So let's go to that place in the land. Do I have a land window up here already? I do. I put that coordinate into my... I did not get it in there. Let's try that again. Copy. Position here. Yes, that's better. There's a space there. I don't want a space in there. We were actually looking where that scene was deployed, but because we hadn't loaded our browser again, you don't see a newly deployed scene if you're already in the world. If it gets deployed while you're in the world, you don't see it unless you reload the browser. In fact, I don't think even the /goto command will show the new scene. At least at this time, that's my memory. But if you reload the browser, our scene is here amongst this other stuff that we saw here before. This was blank land a little while ago. So now our scene's sitting here. And the tree's not actually leaning. It's that there's a kind of a barrel perspective distortion here. Okay, so let's go back to our agenda and see what I have skipped or not gotten to yet. We've pretty well covered what's in the scene. Now let's look at the sample scenes. So Decentraland has provided a whole bunch of sample scenes, and other people have too. They typically reside in GitHub or GitLab. So if we go to Decentraland, it's the only URL you really have to remember unless you have access to the beta, because all the other things are linked from the menus. So we'll go to docs. And what were you kind of... I blanked out on what we were about to look at. I'm sorry. Sample scenes, right. If you go to their website. Okay, try it again. And go to their docs area. There's a piece of the menu that has the sample scenes on it. Clicking on docs. Down here, scene examples. And there's a list of them, of scenes that demonstrate various things. This one demonstrates animation of a shark. This one demonstrates a door opening. This one has a sliding door. This one plays music from a jukebox. It has a scene for what happens if you click or walk near various objects. There are events generated from that you can catch in your script. Anyway, the list goes on. Particle generation for smoke, various types of games, things moving. This, I believe, is an animated as well. It's, there's two types of animation. Let me just mention this. There's two ways you can make something move in Decentraland. One is using the update in a system to move it a little bit every 30th of a second, maybe along a waypoint system or along a path or randomly, as may be the case. The other way is the object itself can contain animations. Each of these scenes has a couple of links here. One is to go see the scene, and the other is to get to the code of the scene. So let's pick this one. Let's explore this scene. Oh, it's hosted on Now. Now is a free hosting site for applications and websites, and it's slower to load than the preview or the world itself. It also this is a little bit older scene, built with an older version of the SDK, so you'll see a little different logos and stuff here. But the scene, these scenes I think are all compatible with the latest version of everything. So he's moving around, and I think he detects when you get close to him, and he gets excited and decides to come after you. Ah. There, he's animated. Animations can take a little while to load. So his animation has him walking and holding up his sword when he's attacking you, but he doesn't actually, the animation doesn't move him across the ground. That's being done with a rotator system. So let's take a look at this code for a moment and see if it's simple enough. We can probably see how this stuff works. I'm going to close it. Maybe I'll regret that. Let's go back to the sample scene and get the link for the code. This will take you to the GitHub repository. And does that directory structure look familiar? Here's your source directory, we see your models. Inside the models here, you probably have the various, the narc, and the wall, and the arch, and things like that. This particular scene seems to have uploaded both the binary compressed and the not compressed version of the GLB and GLTF, and there's that's convenient for us. There's two ways you can get this onto your machine. You can find the download link. Oh, I went down into a directory. You need to go to the top level here, and there's a pull down here. You can download a zip of it, or you can get the HTTP representation of it for pulling using Git. I'm actually going to do that, so if you haven't seen this before, you've seen what downloading a zip and putting it into a scene looks like. I have Git installed, so if I click here, I've copied this link into my clipboard, and this scene is called, what do they call it? Narc Patrol. Okay, so I'm going to go into my experiments directory and make a directory. It doesn't really actually, no, I don't have to do that, because if I go git clone, Control V to put in that URL, it will actually pull that whole directory into a subdirectory named Narc Patrol. I think I will close the scene here. I don't want this stuff to get too impactful on my machine. Okay, so I'm just verifying that it works. It loaded faster here, and the animation still hasn't loaded, but it loaded a lot faster this time. So let's look at the code for this scene. And actually, let's go ahead and close it. I'm going to be killing it anyway. So there's a code. No, I have to go into the directory. We're going to see a couple of things here that are a little different maybe than what we've seen before. I'm just kind of walking through it quick. Nice thing about code is you can also see the whole extent of your source code over here. And you can even grab this and say, let me go up to the top. I'm actually grabbing the thing that says how much of the code I'm seeing. So I'm just going to walk through this very quickly. There's some points being defined, which is the coordinates of, like the waypoints that he's walking around amongst, and they're being put into a vector. And how long it takes him to turn, 9/10 of a second. LERP is a acronym that stands for something I don't remember exactly, but the idea is I want to go from here to there in a certain amount of time, or a certain amount of movement per interval of time. And it will kind of calculate that whole movement from here to there for you over time. I also have a rotate component because I want him to turn, and I'm attaching those components to the NARC, I believe. Some standard create objects things, like for the temple and the NARC. He has the shape of a NARC, and this animator here is the kind of animator that uses the animation that's inside the GLTF. I'm not going to go into great depth on that, but I'm going to touch on a few aspects of it tonight. It's quite well documented in the documentation. But there's a few steps to it, including that you have to get animations from out of the model using the name of the animation that's in the GLTF and this class here. And each of these becomes a clip of animation. You saw that he did more than one thing. He had a walking animation, he had a turn to the right, and he had where he raised up his arm with the sword. And we start by having him walk, by playing that clip. And then we have a system that gets called 30 times a second. I'm not going to go through every detail here, but basically it's using the logic of walking around amongst the position vectors, the waypoints, and that gets added to the system. There's a wait system that's used for something I'm not sure, but for waiting for a while, and then. This is another system for doing the battle, the raising of the sword and that activity, and then somewhere in here there's got to be something that detects that you're close to him. I haven't studied this, but somewhere in here, there is catching a event of getting close, but I don't see it right now. Anyway, when you get to certain places, he notices you're nearby and he turns around. So that's how that is set up. But what I wanted to do was show you how you get the names of the animations out of the GLTF file, because if you go buy a file like from CG Trader, I'll show you that in a little bit,
and and it says it's animated. How do you know what the animation names are to be able to use here? So if you go to someplace like CG Trader to get a model and it says it's animated, you'll need to get the animation names out of that file. If you're really good with the tools that were used to make it, you can go in and get them that way. But sometimes you just want to get them out of the GLTF. And so since we have the GLTF file here, where's the narc scene? In the models directory. You can't do this with a GLB, but a GLTF file can actually be opened with the code editor because it is JSON. And so when I'm looking for the name of an animation, and I haven't tried it on this particular file, I go animation, and now I'm finding my animations. And once I'm here, the next thing I do is I look for the word name. And here's the name turn left. There's another name walk, another name turn right, raised dead. There's other things in here with names like images, but at the beginning of these sampler sections, within the animation section, you'll find name values, and those are the names of the. So once again, you search for animation, and there's only one of them in here. And then if you find the first name, and if there's more than one animation, you may find that name followed by samplers, name followed by samplers, those are the names of the animations, so that you can use them in your script. Next thing I think I want to do is show you how to go get a 3D model that somebody else has made. I sometimes use TurboSquid. I more recently have been using CG Trader a lot. They both have very high quality models. They also have models that are not suitable for Decentraland because they're too high poly. So you have to look at what you're getting. But if I go to CG Trader, I have some here in my inventory of things that I've gotten, so we might just grab one of those. But if you want to look for something, what you do is you just start with a look. You know, like maybe you want a tree, and there's lots and lots of trees. However, they're not all suitable for use in Decentraland because some of them are very high poly scenes, but some of them aren't. So you can look for the words low poly on the thing, but easier just to go up here to the poly count and say, keep under 5,000, please. Even that number is pretty high. And you can say, I don't want anything that's $500, thank you. I'm going to keep it down to maybe 20 something. Now we have a bunch of trees, right? Some are very low poly look, but you can get some pretty good looking trees that don't look all that bad. Let's see how many polys this has. And the other thing you want to look at is what the model formats are. You can work with OBJs, FBXs, obviously Blender files. We're going to be using Blender. I'm going to demonstrate the use of Blender to take some other file format that Blender can import and export it to a GLB. So let's just take a look at this $2 tree. How many polys does it have? 3,000. That's a little expensive. If you can get things that are under 1,000, they're just hundreds of polys, that's better because you can put a lot of them in your scene. Let's just go. It's a beautiful tree, I must say. Let's go look at one of these like super low poly looking trees. For the real low poly stuff like this, you just get it out of the builder's content. They have some pretty good looking low poly stuff, but let's see if anybody has like a single fairly low poly tree here. $2.10. It has 1,000. Still kind of high, but it's not outlandish. I'm not going to buy something tonight. I'm going to pretend that I bought it and go to my inventory of things I've already bought. One of the nice things about CG Trader is that when you start getting a bunch of models, you can end up with a lot of clutter because you not only have the original file formats, you have Blender, you have GLBs, you have image files, and you can build a content library, which I recommend that you do, that you structure well to store the stuff, especially since you're going to be building GLTF and GLB outputs from these objects that typically don't have them. But finding something in that tree of finding it visually can be kind of hard. So if you stick to a few sources like CG Trader and TurboSquid, they have a place that you can go see what you've gotten, and you can kind of look through it. So I'm just going to work with this pavilion here tonight. I'm just going to show you. That's the one that I had in the center of the sandbox. And I'm just going to download it again and kind of go through the process. So by the way, it comes in. Let's just look at its stats and what it has. It was inexpensive. I've bought a few things, so I actually get some good discounts. It has formats that I can work with. FBX I could import. OBJ I can import. Geometry, for all that decor, it's only 3,000 polygons. So I'm not going to put 10 of those in a scene, but since it's kind of the center of a scene, centerpiece of a scene, I can afford to maybe spend a third of the polys that I have available to me in that one parcel. It's okay. Other things I put around it probably be lower poly. So anyway, you can also reduce the polygon count on something by decimating it some or taking away some of the geometry. So back to my where I can download it. It's right here at the top. Got it recently. Download that. I'm going to download this RAR file. It's kind of like a zip file. And I'm not going to try to put this into a nice clean place where it ought to be. I'm going to instead work with it kind of right here. So the first thing I'm going to do is open it up. I have WinRAR on my machine, and it can look at what's in here. I see that there's some materials available. They're actually texture files. And in here I have two formats of that model, the FBX format and the Max from 3ds Max. I don't have 3ds Max on my machine. It's kind of expensive, but I do have Blender, and Blender can open an FBX file. So let me put this someplace useful. I'm just going to, in my downloads directory for now, I'm just going to create a new directory here at the bottom, actually just called new folder pavilion. This is not what you want to do if you want to organize your stuff well, but I'm not going to try to demonstrate that tonight. And then I'm going to take the FBX file out of here. Actually, I think I'll take all the files out of here because I might need those materials. I happen to know I don't, but that's because I've played with this before. But sometimes you need the materials. So I'm going to go in here, and here's my FBX model. I'm going to open up Blender 2.80, which is the new version. It's a much nicer, more learnable interface than the older version of Blender. And you can really go to town learning how to do all kinds of modeling and texturing and animation, etc. in Blender. But for tonight, I'm mostly just going to use it to show you how to turn a foreign model type like an FBX into a GLB file. So you just click on the splash screen to get it away. And you start with a default scene that has one cube in it. It's useful if you're doing a lot of fast modeling, because when you're doing modeling work, very often you start with a cube and distort it in various ways. But we're not going to use anything from this cube. I deleted it by clicking on it and deleting. I'm going to instead go File, Import, GLTF. Nope, FBX. And I'm way off some other place, so I'm going to come back here to my Explorer and copy that path and put it up here, Control-V. And now I see this FBX file. So I'm going to double click on it and see what I get. Just a few little simple things about Blender. Again, this is not a Blender tutorial, but up here in this, in the default view, or the default workspace of a new file in Blender 2.80, because remember we did effectively a new file. If you wanted to start over, you could go File New, General, and we'd end up with that box again, and this would be gone. The default has these tabs of different types of workspaces for different tools. Or the kind of different view environments. For example, this is just for like laying everything out, whereas if you wanted to look at the way that the shading nodes, like how color and stuff are applied here, there's another view called shading. If you wanted to work on building an animation, here's your timeline. So a lot of the work is just done in layout and maybe in shading. The two you'll use a lot. These buttons up here tell how do I want to look at this thing? How nicely do I want it rendered? And if you go click on the one on the far right, you get it rendered very much like it would look in Decentraland. It's nicely rendered. And the new Blender has a very fast renderer. So I can, fully rendering it in real time, I can look around. That did not used to be the case in Blender. There's one thing I don't like about this model is why is this roof up in the air? So let's move it. I'll show you how to move something. I'm going to start with my tool here being the selection tool. I'm going to kind of just draw a box that grabs that roof. And everything lights up there because it's selected. I'm going to hold down the Alt key, click on the ground, and tip around and make sure that it's all selected, which it is. And then I'm going to go to the Move tool. This kind of a little reminiscent of the Builder tool, right? There's Move and Rotate. There's also Scale. So click here, and now I have tools for moving this thing. I'm just going to put the roof. Oops. I must not have the right thing selected because it didn't just move the roof. So Control-Z, very nice. Not sure what I selected that I don't want to select. Let me go at this angle and select from there, like this. Oops, selection tool. Grab here. Move tool. Oh, I'm getting too much still. Well, when I practiced this, I didn't have that problem. So maybe it's because this thing's already selected. Let me just select something else here. Okay, now let me use the select tool. Select just that. Not sure I still selected only just that. There we go. All right. Approximately. I could look at this much more carefully and figure out. But anyway, roughly, this shows you can make a change to a file. I'm not going to play around with shaders quite yet, but it's because I want to show you what it takes to export this. So the first thing I want to do is I want to save this as a Blender file. So next time I don't have to do the import. I don't have to start over again. So I'm going to save as I'm going to put it back in this directory here. And let's call it pavilion.blend. And then, I mean, that gives me the, just a quicker starting point. If I open this back up, I'm right back here. And then I'm going to have nothing particular selected. Going to go File, Export as a GLTF. GLTF is the format, but there's actually a few different file arrangements of that. GLTF has all of the texture files and the binary mesh as separate files in addition to the GLTF file. GLB packs all that stuff together and compresses it into a single file, and it's a good file format for your production of your kind of your final delivery for deployment. So I'm going to use that format. It's asking me how and where do I want to export this. I always click Add Modifiers. In fact, I have some presets here. My DCL GLB, which I've set up, turns that on. You also definitely want to have it say treat up as Y. Otherwise, you're seeing, if you turn that off, I think maybe Z is up in their coordinate system, but I want up to be Y. So you want these two things on. There are some models that have modifiers, and you have to apply them for it to look right when you export them. So I don't always know whether there is one, so I just turn that on. There's no harm if there aren't any. It looks like it knows that this file, this Blender file, is called Pavilion, so it's going to give me a pavilion.glb file because I've picked on this little guy here GLB, not GLTF. Or GLTF embedded says give me a GLTF file, but stick all the other stuff in it as blobs. This says give me separate a JSON file for the GLTF, a bin file for the mesh, that's a binary file, and all my texture images, all as separate files. That can be convenient when you want to look in here for an animation name, or if you want to play around with the textures after you've exported it, maybe change the size of them, make sure they're square, etc. But I'm just going to make it a GLB. I happen to know that this particular model doesn't have any texture files. It only uses its colors from material definitions. So I'm going to go ahead and export this into that same directory. And when this comes back, by the way, the very fact that I did an export may touch the Blender file in some way. So I'm going to actually close this Blender. It's going to say, do you want to save it? And I do. I think it's because it noticed that I changed the setting down here. So I couldn't save that. And it always keeps the previous version of the Blender file as Blend 1. And now I have a pavilion as a GLB file. I double clicked on it and I'm looking at it in the 3D Builder in Windows. There's a tool I just want you to bring to your attention. It's a little obsolete for our work, but it's sometimes useful just for looking at something, which is the Babylon Sandbox, the Babylon JS Sandbox. And the reason it's useful is you can grab either a GLB file or a GLTF file and multiple select all the things that go with it and drag it and drop it into here, and it just gives you a view that is just a little bit more likely to tell you what it's going to look like in Decentraland. It's just another way of validating a file. Like, for example, if somebody sends you a GLB or a GLTF file, you just want to see what it looks like. You can either double click on it and your operating system may have a viewer, or you can use the sandbox.babylonjs.com. Not going to spend a lot of time with that, but so let's put this pavilion into our scene. So I'm going to Control C here and go back to my Demo 2 scene. when I make a new directory here under the models directory, I could just drop it, I could place it almost anywhere and just give it the right path. But this is just organizational. So I want to say pavilion. I'm using a capital P on the folder name and on the GLB name. So I come back to my source game.ts file. Let's just add one more thing in here. Let's add a pavilion. I'm just going to be lazy as a programmer. By the way, this is what professional programmers actually do, is they copy and paste code a lot. I get some syntax errors here because now I have declared tree pine twice. So this is really going to be pavilion, right? In fact, let me show you a trick here. If you have a lot of things to change, and you want to use Code's wonderful tools for changing all the instances of a variable name, is you can comment out the part you want to keep and not change. And then in here, I can rename these things one at a time. So I want to call this thing the pavilion entity, right? So I just call it pavilion, rename symbol, pavilion. Variable names usually start with lowercase. The case here, in fact, the word has doesn't have to match the model name. It's just convenient if it kind of does. But as a variable name, I usually start with the lowercase. It is parented by the scene. That's good. The GLTF shape, well, I don't want the one from that tree, so I'm going to grab this line of code here because it's kind of the right kind of code, and I'm going to stick in something that'll pick up the, let's just call this thing pavilion shape. Pavilion shape. And I'm going to pick up the pavilion GLB by changing this to be pavilion directory. And notice that except for in Windows Explorer and Command, within most coding languages, TypeScript being an example, you use forward slashes instead of backslashes. Even though you're actually in Windows, pavilion. I want to use this shape when I add it to the pavilion. We're going to come back to this stuff in a moment. And the transform I want to use is not the one I've copied from up here. I want to call this, I'm going to rename this one so it won't fight with that. Pavilion transform. By renaming it, it also fixed it down here what was being used. Just kind of gradually looking at all the other variable names here, they look pretty good. So this would actually appear where that other tree is. Maybe that's not where I want it. Maybe I want it somewhere else. So I'm going to re-enable this, and we will see that the tree and the pavilion are superimposed. Yeah, if I've typed everything correctly, we'll see a pavilion in the scene. If we don't, we're going to do some debugging. Right where the tree is. Nice. And it's also up in the air a little like the tree is. So we could tweak these numbers for a while, but I'm going to show you something kind of cool that I made and that you are welcome to use. And that is a builder HUD. You can use to move things around in the scene and get new coordinates for them. So if you go to my GitLab, this guy right here, DCL Tech Builder Hub, actually, I'm going to go back to, yeah, no, this is good. I'm not going to try to download the whole thing. Oh yeah, actually I already have this on my machine. That'll be faster. But if you could see all the stuff that's in here, but I already have it on my machine. So instead, I'm going to find where it is. actually it's here, okay. TCL, it's in a folder I call library, and maybe I'll use this version, scene base. Okay, so I'm going to right click on this and pick this wonderful tool called Beyond Compare, and say I want to compare this directory to my demo directory. Right click here and compare to the scene base. It's this icon right here, Beyond Compare. I highly recommend it for work like I'm about to do. So the builder HUD requires a few things that I don't yet have in my scene. So it requires this module of source code. So I'm going to copy that to the right, and it builds the whole tree structure I need over here. I also want to use spawner function. It's another thing that's really convenient that works nicely with the builder HUD. Remember, we had a spawner function for a box in the DCL init scene. Amongst the models, I need both of these guys. They're part of the builder HUD. Copy to right. And there's material that is the builder HUD UI material. And copy that to right. What I've just done is I've just placed into my scene some pieces of things that are needed to do what I'm about to demonstrate. So this is kind of an example of borrowing code from another scene, like from a sample scene. I'm borrowing from something I made myself. And the other thing I'm going to do is I'm going to open with associated app the game.ts from that sample scene. And I'm going to bring in two import statements. An import statement brings in another file of TypeScript. So when your projects get really big, you don't want to put the entire project into one file. So you're going to kind of take sections of it and put it in another file. It's especially true if you're using utilities like the spawner functions or the builder HUD from somebody else. They're going to give it to you as a separate file. So you need to know how to import it. So you say import from the module subdirectory of source, the name of that file, and then you list which methods or classes from that you're going to use. So I want to use that one. Put that in my demo 2 at the top. And I'm also going to use the import of the builder HUD. And I'm going to uncomment it because I'm going to use it. And then I'm also going to, I think that's about all I need to do from there. Okay, so back in here, I'm going to say I want to move that pavilion around more easily and get it adjusted exactly where I want, size it, rotate it, whatever. So I'm going to say HUD, no, const HUD equals new builder HUD. That's green because it recognizes that from that import. And then I'm going to say HUD attach to an entity, and the one I want to attach to is pavilion. Code typed more than half that text for me, by the way, because it knew what I could possibly put there, and I just had to type a letter or two of it. What this is going to do is going to create a user interface that pops up in the lower right part of the screen when I'm working in the scene, and it's going to say I want to use the HUD to move pavilion around. So now if I go in my scene, did it reload? Yes, it reloaded. And the HUD shows up here. It's collapsed right now. And by the way, just so you'll know, if you decide to use it, and you're welcome to, if you step out of the scene, it disappears. User interfaces can only appear This is a Decentraland rule when you're in the scene where they're defined, so you don't carry them with you and just clutter up somebody else's scene. So if I click on this HUD and it expands, and there's some buttons there. I only attach to one object, so I don't need to use these selectors to say which object do I want to move. And as I select different objects, there's a red pointer that usually appears over them if they're not too tall. One of the things that I did apparently is that I got the transform from this tree, so the pavilion is twice too tall. That's kind of funny. I want to move this thing, and it is the only thing I attach to, so I'm just going to start moving it. So I can click on this to say, do I want to move it? Do I want to rotate it? Do I want to scale it? Well, let's first of all scale it down to more like a pavilion. That's a pretty good, reasonable size. And then I want to position it over here, and maybe not quite that far. Let me fine-tune this a little bit. I'll change it to 1/10 of a meter. There. You can see the selector is hanging out in here. And then I want to move it down a little bit onto the ground. Now, I need to turn my scene down so I can see when it disappears into the ground. I don't want that. There, that's too far. That feels just a little low. So why don't I go down to millimeters and just bring it up just a little teeny bit. It seems like it's on the ground. Okay. And maybe I want to feel more like that door is right toward me. So I'm going to put it on rotation. I don't need to rotate it 90 degrees, maybe just like 5 degrees at a time. And is it this one? Yes, but this direction. It's just like right to me. There. Now, what do I do with this? JavaScript can't write back to your game.ts file. It's just not allowed to for security reasons. Otherwise, websites would be writing all over your file system. So instead, there's a save button here. And where it saves to is the console, the debugging console of the browser. You open that up on just about any browser these days by hitting F12. So I'm clicking on F12, and up comes a pane over here on the right that has various tabs at the top. The one called console is the one you want. And the builder HUD wrote out some coordinates between these sections of lines. There's only one thing in here that it was editing, but if you'd attached a lot of things, you'd see a number of things listed here. But here are the coordinates of that object. So I'm going to take those and just bring them back into my editor as a comment. The first three are the position. So I'm just going to stick them in here. The third three are the scale. So I'm going to change it being twice too high to being the right amount too high. And then these are Euler coordinates of the rotation, but I have a quaternion rotation item here. So I always forget how to do this. I know I'm going a little over time, but this is the last thing we're going to do tonight. I go back to the docs because I can't usually remember how to do this quite right. There are several different ways you can use Eulers and quaternions interchangeably, and maybe move actually contains rotate, I think. Nope, not move. Is there a search here? Euler. Position, rotation. Like I said, it starts. Maybe there's some information about what quaternions are there, but the way you use a Euler in setting up a rotation in this syntax is to say quaternion, not new quaternion, but quaternion.euler and the angles you want. So I'm going to use this and replace new quaternion up to there with that quaternion.euler, and then take my rotation coordinates here, put them here. And the reason why this HUD is useful is that, can you imagine trying to come back and edit this and make little teeny adjustments like 0.25 and reload and edit and reload and wait a minute, I turned it the wrong direction. The HUD it's taken about half the development time for me out of scene development. So I'm saving it, looking back here, this should reload, and the HUD is still attached to it, but it's where I put it. So now I can simply comment out the HUD work. I may want it later, but let's comment it out for now, and the HUD will go away. So you're welcome to go to GitLab. The URL again is GitLab DCL Tech. It's not Decentraland site, it's just what I called my group for this. And there's a number of scenes in here that are projects that are public. The Builder HUD and a lot of things are in the scene-based code, but there's a demo of it here. There's a demo of a simple waypoint system you use to make things like birds fly around between trees. I made this scene because sometimes I have a hard time figuring out how to rotate a panel of a box or a plane when I have writing on it. I put it in the scene and it's upside down and backwards, and so this helped me kind of figure that stuff out before I had the Builder HUD. And you're welcome to borrow any of these things and use them. That's it. I think that's all I'm going to try to do in this roughly 2-hour session. So thank you very much, and I hope this was helpful. If you want to get in touch with me, in Discord, you can find me in a number of the Discord district channels. The university channel has a VR Academy set of channels in it. So you could go to the Decentraland Discord. You could follow the links to any of those. You go into the channels for any of these districts. You look for links there to their own Discords, and you'll find me around in there. Right now I'm very active in the university, the conference center, theory, and VRS. So you're welcome to get in touch with me, ask questions, and I might even answer them. All right, well, thank you all very much, and good night.